that is an inclusion of the non-local,
Yeah.
which is continuous.
Yeah.
Very simple.
Yeah, no problems with that.
Okay, so we now, instead of thinking about stopping points along a line, start thinking about overlapping spheres of influence. Well, we can, to form a channel, and this is actually, I drew this, I've drawn this picture here, and Jack may show it at some stage, but essentially, here's our classical way of thinking about numbers, in terms of a discontinuous line of discrete numerical points. We include space, and we go from that that discontinuous line of discrete numerical points to a continuous channel, or a resonant channel of reciprocal. Well, what we can do is, if we think about each sphere as overlapping with every other sphere in its neighbourhood, then actually we overlap those. And what we can create out of that, and this actually leads to Lere's idea of, if instead of thinking of numbers in the conventional way as 1, 2, 3, etc., as isolated discrete stopping points, we actually think of every number as having its own central identity, and which is an inner identity, and an outer identity, which is its neighbourhood. Yeah. Instead of representing, say, the number 2 as number 2 on its own, we represent the number 2 as 1, 2, 3. Yeah. So we've got the core identity of 2. Yes. And we've got its neighbourhood of 1 and 3. Okay. And of course, the number of 3 is 2, 3, 4. Number 4 is 3, 4, 5. So we suddenly converted a series of stopping points, yeah, into a series of overlapping, and hence we've converted this whole system into a continuous channel. So each numerical identity, yeah, is both itself.
I agree with that.
It's both itself, and it's both its inner self and its outer self in terms of its environment, its neighbourhood.
My problem with this, I understand what you're saying completely. 1, 2, 3. So that would be 1, 3. Well, that would be 3, 1.
Oh yeah, you can think about it overlapping in all sorts of ways, yes. So, and you can think about this nested over all scales as well.
Right. So how do you represent? So if I want to add 2 and 2, I want to add 2 and 2, and I've got 1 and 3, 3 and 1, 1 and 3.
All that kind of stuff. You can.
How do I make sense of that?
You can still do it, believe it or not, in exactly the same way as with the classical numbers. But what is changing is your understanding of the nature of the numbers.
Okay.
Okay. I won't go through that because it's quite complex to try to illustrate that.
So therefore,
but essentially, you can actually treat fluid logic numbers, as these are called.
So if we come to 4 here.
Yeah.
So 2 plus 2 equals 4. So then 4 is then extends out.
You can think of it that way. But again, the part of these issues with numbers, what you're beginning to get is we've moved to a situation where 1 is included in many, and many is included in 1.
Yeah. This is almost 5 dimensions in that one plane.
That's the 5th dimension, yes. The 5th and infinite dimension, which arises when you include space. So essentially what you've done by including space is you've inflated what was a dimension, a one-dimensional line, yeah, into a dimension-full channel, where every number is an inclusion of every other number. Yeah, and we've also done some very interesting things because in terms of how each number relates to the other, and there is an intrinsic geometry in here which we can sort of almost just see arising. Is if we take 2 adjacent spheres, there is an overlap zone, yeah, and we look at the central identity within that overlap zone. And we see how one can, this overlap zone is essentially a place of flowing into and flowing out from. Yeah, we can understand how this domain here is related to its immediate neighbours, yeah, simply by drawing in, yeah, a series of progressively halving hemispheres, and we actually get the geometry emerging of this wonderful fold form, yeah, which this is known as the alpha fold, and it's got a reciprocal omega fold which goes the other way, so that every core identity of every numerical of every number is a place both of flowing into and flowing out from, yeah, simultaneously. And if you look at this very, very carefully, you can actually see that we have the geometry of DNA is in there, because we've essentially got the the 5' strand which goes in one direction, the 3' strand which goes in the opposite direction, when we're understanding that flow is always reciprocal. Yeah? We've always got, it's like tidal, you've got the flow in, which is always accompanied by the flow out simultaneously. And that gives rise to a completely new mathematics and a completely new geometry and understanding, where instead of sort of fixing our geometry in this cubical form, we've essentially got a geometry from which cubes can be derived. Yeah, you can easily derive the cubes, but they're not what we start with. What we start with is overlapping spheres of influence, or what I like to call overlapping local spheres of non-local influence. So, okay, so we've got the locality in terms of what we can distinguish in a figural form of spheres, and we've got the non-locality which is included therein, and you expand this over many scales and you get the geometry of nature.
Can I ask you a question on that?
But
after you've done that, if we could move quickly on to...
If we do this painting next, I think that would do really nicely.
Yeah.
I just got to understand this in my head now.
No, well, it took me years.
I'm sorry.
Just to give you a flavour. It took me absolute years, and in fact, when I finally did this, and I finally showed Lere that form, he said, "I've never seen that." You know, he said, I didn't believe it was possible to explain this more simply, but now I know that it is.
Fantastic.
1, 2, 3.
Yeah.
1, 2, 3. Or 3, 2, 1.
Yeah.
Or 1, 2, 3. Each one of these is separate tubes.
Yeah. Well, they're not separate, of course,
Oh,
but you created a world. Yeah.
You can have these flows between.
Yeah.
So 1 plus 2 is 3 goes off in that direction. 1 plus 2, 3 go off in that direction.
Yeah.
So you've got these flows that move within.
Yeah.
That's where your interconnectedness comes from.
Well, communion.
Communion. Sorry, I
See,
changed your word. Sorry.
Well, it's really important because, but this also shows you the difference.
Yeah.
That is interconnectedness.
Yeah.
Okay, which is just the contiguity of adjacent explicit material form. This is communion, where you've included the space.
Yeah.
So there's a real difference between the notion of...
I understood your interconnectedness to include the space. I didn't realise it was separated.
No. Well, I mean, that's because I'm learning as I'm going along too, and changing my language as I'm going along. But what
change it after my PhD.
What?
Not before.
I mean, that's how it goes. Is that, you know.